Ms. King here, and in this screencast, we're going to look at the metric system. You have two indicators for your South Carolina end of course test that look at the metric system. The first indicator is making sure that you use the appropriate lab equipment to make metric measurements, and the second indicator is making sure that your measurements are accurate and precise. So to begin, let's just take a look at the International System of Units, or SI. That is the same thing as the metric system. So you can call it metric system or you can call it the SI system. They are both the same thing. We use the metric system for two reasons. One, because it's used globally. The metric system is used in every country on this planet except for two, and the United States is one of those two. The other reason is because it's easy. It is in multiples of 10, so it makes it easier for us to convert from one unit to another, because all you really have to do is move a decimal point. And we'll look at how to do that in just a few minutes. Here's an example of why metrics are important. This is an article from CNN.com that explains something that happened with NASA back in 1999. It says that the failure to convert English measurements to the metric values caused the loss of the Mars Climate Orbiter. That means that that satellite crashed because we didn't use the metric system. So that's a pretty big deal that happened, all because we didn't use the right type of units for our measurements. So using the metric system is really important when we do science. These are the different types of measurements that we'll be making in science class. You need to know how to do length. So to measure length, we are going to use the base unit of meters. And you'll need to either use a metric ruler or a meter stick to measure meters. And just to give you an idea, 1 meter is about the length from your doorknob to the floor. We'll also be measuring mass. To measure mass, we're going to use the base unit of grams. We'll need a triple beam balance, and you could use a scale, but you need to make sure that your scale is set to grams and not pounds for the measurement. And to give you an idea, 1 gram is about the mass of a paper clip. Volume is also one of the measurements that we'll be making in biology class. To measure volume, we're going to use the base unit of liters. And we always want to try to use, as our tool for measurement, the graduated cylinder. It has graduations, and those graduations are precise and accurate. We can use a beaker to measure volume. However, not every beaker is graduated. So if you have one that doesn't have the graduation lines, you can't use it to measure. So the best tool to use is always going to be the graduated cylinder. You can also use a pipette, especially if you're making measurements that are very, very tiny measurements. Most of the pipettes are graduated that we're going to use. Just to give you an idea also of about how much a liter is, this is a 2-liter soda bottle, so 1 liter is about half of that soda bottle. And then, of course, temperature is one of the measurements that we'll be making in biology class. And for the metric system, we always want to make sure we use degrees Celsius. Fahrenheit is the American measurement, so make sure that you're doing Celsius for your measurements. And, of course, we'll use a thermometer for that. Let's take a look at some practice questions really quickly. You tell me what the appropriate equipment would be to measure each one of the following. So what type of equipment should we use to measure 3 milliliters of water? Milliliters, liters is a measurement of volume, and this is a liquid, so we would need to use a graduated cylinder. Is that what you said? What about this one? How will we measure 27 centimeters? 27 centimeters, we would probably want to use a metric ruler for that. That is a measurement of length, meters. All right, what about this one? To measure 100 degrees Celsius. Well, we know that degrees Celsius is a measurement of temperature, so we would need a thermometer. And then what about this one? How would we measure 5 grams of sugar? Well, grams is a unit of mass, so we would probably want to use a triple beam balance to measure our sugar. These are the types of questions that you may see on a quiz or a test or even your end of course test. So please make sure that you know what type of equipment to use for different kinds of measurements. And we will practice some more of these in class. And here are some other places that you will see metrics here in the United States. Even though it's not often that we see metric measurements, there are some things that you might be familiar with, like if you're on the interstate, you may see the given kilometers on the signs or even on the speed limit signs. You can look on some of your food products. You'll see that it says 1.19 kilograms, so you might see the measurement of mass in kilograms. And also here's a big one that I see in class all the time. I hear you asking for to borrow lead for your lead pencils. Some of you, ask, do you have a 0.5 or do you have a 0.7? Well, what they're talking about is the size of your lead, and that is measured in millimeters, so that would be a metric measurement. Alright, so let's look at doing metric conversions. To do metric conversions, we need to make sure we're familiar with the prefixes. If we start with our base unit of 1, if we go smaller to a smaller unit, then we're going to go to the right, and each step that we go is going to be 1/10th, and then this is 1/100th, and then this is 1/1000th. And then we can also go up to a larger size by going in this direction. So we go from 1 to 10, from 10 to 100, and from 100 to 1,000. You definitely need to know the order of the different prefixes: kilo, hecto, deca, base, deci, centi, and milli. And I'm sure you all probably remember the trick to remember the correct order, and that's King Henry. So King Henry died by drinking chocolate milk. K for King, H for Henry, D for Deca, B for base, D for deci, C for centi, and M for milli. Make sure you know King Henry died by drinking chocolate milk. Alright, on a piece of paper for your notes, if you'll go ahead and draw a line and then add 7 tick marks. If you need to pause the video, you can pause to fill in your notes. Once you have your tick marks, go ahead and write the abbreviations for King Henry at the top for your units: kilo, hecto, deca, and then your base, deci, centi, milli. And make sure when you do your base that you put meter, liter, and gram. Now, for those of you that feel like you're not comfortable with the abbreviations, you may want to write the whole word out just to be sure that we don't mix up any of our abbreviations. Okay, so if you need to write kilo or hecta, oops, or deca, but especially over here, if you need to write milli, go ahead and do that, because we don't want to mix up milli and meter. Okay, and I see that a lot. The one M means meter. If there's two M's, it means millimeters. Okay, so be really careful not to mix those up. If you need to write the whole word out, write it out. Alright, and so when we make metric conversions, what we're going to do is take our decimal, so here's my little decimal point, and we're going to just simply move it to where it needs to go. So if I give you an example, like if we have 9.2 kilometers, but I want to change that to how many, we'll say, meters is that. Okay, so we start these problems by first looking at where do we start. Well, here's where we're starting, at kilometers. So what we want to do is take our decimal, and you can use your finger as your decimal, and we're going to start right there on kilometers. Okay, K stands for kilo. Now the next thing we need to do is to determine what direction our decimal needs to go. Does it need to go to the left, or does it need to go to the right? Well, where are we going? So we come down here to our problem. This is where we're going, meters. And meters is right here, so that means our decimal is going to need to go to the right, okay? Because we're going to take our decimal and we're going to move it from kilo, 1, 2, 3 places to right here, which is where we want to go. So we have to come down here with our pen, and we have to move our decimal 3 places to the right. So we're going to go 1, 2, 3, and that's where our decimal goes. And now we have these 2 open spots, and we're just going to add a 0 to them. So what we're going to end up with for our answer is 9,200. Okay, let's do another one of those. Let me clear my screen. Okay, so if we have, let's do 0.01 centimeters, and we want to convert that to, let's do meters. Alright, so we're going to find our starting place, which is centimeters. So I'm going to put my decimal point right here on centimeters. And we want to go to meters, which is, again, right here. So this time, to get from centimeters to our base unit meters, we're going to have to go to the left. Okay, so we're going to move our decimal point 1, 2 places to the left. So we have to come over here to our problem and move our point 1, 2 to the left. And now we have an open spot that we'll fill in for a 0. And that gives us 0.0001 for our answer. Okay, so basically we're just moving our decimal from where we start to where we want to be. Okay, and if you need to draw the line with the tick marks when you work these problems out, then that would be a good idea. Let's look at some practice problems. All right, again, to convert kilograms to grams, we're going to start right here with our decimal on kilo. And to get to grams, we need to go to here, which is our base unit. So we're going to go to the right, and we're going to go 1, 2, 3. Okay, so our decimal point with our 8.9 needs to go 3 places to the right. 1, 2, 3. And then we have 2 open spots to fill in. So that would give us 8,900 grams. Okay. For this one, number 3, we want to go from decameters to centimeters. Well, we're going to start with our decimal on deca, and then we're going to need to move it to centi, which is way over here. So again, we're going to the right 1, 2, 3 spots. So when we come to do our problem, we have 0.079. We need to go 1, 2, 3 to the right again. 1, 2, 3. And so we end up with 79 centimeters. All right, so number 5, we have 9,800 deciliters. So that means that we are starting way down here. Let me grab my decimal. So here's our starting point. And we want to go to kiloliters. So that's 1, 2, 3, 4 places, and this time to the left. So we need to move our decimal 4 places to the left. First of all, this number, where's the decimal? It's not there. That means that it's automatically at the end. Okay, so we're going to move it 4 places. 1, 2, 3, 4. All right, and so we end up with 0.98 kiloliters. All right, I'm going to do one more. Let's do this one down here. 2.2 kilograms. All right, and let's do our decimal. So we're already up here at kilograms, and we want to go all the way down here to milligrams. So our decimal is going to go 1, 2, 3, 4, 5, 6. So we need to move our decimal place 6 different places to the right. All right, so 1, 2, 3, 4, 5, 6. And then we're going to fill in the empty spots with the 0. All right, and so we end up with 2,200,000. And that's milligrams. Okay, what I'd like for you to do is you may need to pause the video, but I'd like for you to copy down the 4 even numbered problems. That's number 2, number 4, number 6, and number 8. If you'll copy those problems down and work those out, and then I'm going to check those for homework when you come in. All right, and that is how we make metric conversions.